In this video and in our next video, we're going to look at absolute value equations and inequalities. In this video, we're going to focus on absolute value equations, but let's first just review the concept of absolute value. Absolute value is your distance from zero. So this particular graph illustrates that there are 2 points that are both 5 units from zero, 5 and -5. So this idea is how we set up the idea of how to solve an absolute value equation. If we know that a is greater than 0, then the absolute value of x that equals a is equivalent to x equals a or x equals -a. Now, we do require that a has to be greater than 0 because if we have absolute value equal to a, that's saying the distance is equal to a, and we can't have a negative distance. Now, this is a very simplified rule. You want to keep in mind that this x and this a could be expressions of multiple terms, but we're going to apply it the same way. First, let's just visualize the solutions for the absolute value of x is equal to 3. So if we think about a number line, what we're saying is, if we're saying the absolute value of x is 3, we're saying the distance that x is 3 units from 0. So this is 3 units. And we can also go to the left 3 units. That tells me that x can be -3 or x can be +3. Those are the two solutions of two values that are 3 units, exactly 3 units from 0. Likewise, if we're thinking about the absolute value of x is equal to -3, we kind of just talked about this. That's saying that x is -3 units from 0. Since distance cannot be negative, there is no solution. The steps for solving an absolute value equation, we're going to start by isolating our absolute value bars. So everything that's inside needs to stay inside. Everything that's outside the absolute value, we want to move to the other side of the equation. We're going to apply the absolute value property, and then we're going to solve each of the equations. So applying that absolute value property ends up creating 2 new equations without the absolute value bars, and we'll solve each of those individually. So solve the equation. Absolute value of 3x plus 5 equals 14. The first step is done. The absolute value is isolated. So the second step is to apply that absolute value property. Which is that 3x plus 5 could be 14, or this 3x plus 5 could be -14, because both of these 14 and -14 are 14 units from 0. Let's think about this visually before we move on, just to maybe help us understand a little bit better. So here's our 0, that's the middle, right? We're always talking about the distance from 0. We're talking about this thing, this 3x plus 5, and we're saying that it is 14 units from 0, which means this 3x plus 5 could equal +14, or the 3x plus 5 could be equal to that -14. So that's how we're setting up these two equations. We're going to think about the same idea when we transition into inequalities in a little bit, or in our next video. So now we've got these two equations. We're going to solve them. I'm going to work with one at a time. Subtracting 5, we get 3x is equal to 9, x is equal to 3. Subtracting 5, we get 3x equals negative 19. X is equal to negative 19 over 3. So we've got two solutions for this particular absolute value equation. Absolute value of x minus 3 plus 8 equals 4. So now we need to do that first step of isolating the absolute value. So we're going to subtract 8 from both sides. We end up with absolute value of x minus 3 is equal to negative 4. Well, we just illustrated an example where if we have the absolute value equal to a negative, that there's no solution, because absolute value, that term on the left, is representing a distance. And what this says is that this distance is negative 4 units, which is not possible. Absolute value of 2x minus 1 minus 5 equals negative 3. So again, starting to isolate the absolute value, we've got the absolute value of 2x minus 1. By adding 5 to both sides, we get equals, positive 2. So we have the absolute value of 2x minus 1 equals 2. We're going to apply the absolute value property. So 2x minus 1 is equal to 2, or 2x minus 1 is equal to negative 2. And solve both of these equations. So starting with the first equation, we have 2x equals 3. X equals 3 over 2. The second equation, so adding 1 to both sides, we have 2x equals negative 1, or x equals negative 1/2. Yeah, let's do one more. 5 minus the absolute value of 4x plus 3 equals 2. So again, we've got some isolating to do. We're going to start by subtracting 5 from both sides. So we have negative absolute value of 4x plus 3 equals 2 minus 5 is negative 3, which in the past is an issue, but we have that negative coefficient out front, so we still need to divide both sides by negative 1. So we actually have the absolute value of 4x plus 3 is equal to positive 3. Applying that absolute value property, we've got 4. Let me come up here. We've got 4x plus 3 equals 3, or 4x plus 3 equals negative 3. And we're going to solve both of these equations. Subtracting 3 from both sides, we have 4x equals 0, or x equals 0. Again, for the second equation, we start by subtracting 3 from both sides. We get 4x equals negative 6. X is equal to negative 6 over 4, which we need to simplify. So x is equal to negative 3 over 2.